Hi everyone, welcome back to the channel here at The Construct, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Ruben, who took our course ROS Basics in 5 days for C++. He'd done the Python course and beforehand. Now he's showing us what he did for his final project. So all our courses, not all our courses, some of our courses offer a project that you can try out in a real robot here at The Construct. So he's going to show us that, his project for ROS Basics in 5 days for C++. So without further ado, hello, Ruben, how are you?
Hi, fine, thanks.
Great. Whenever you are ready, please start sharing your screen and just tell us what your project's all about.
Okay.
Great, we can see your screen now.
Okay.
Resize it.
Well, the project has 3 parts. First of all, we need to create a service server to make the robot put on parallel on the wall.
Which is what it's doing now, correct?
Yes. We see the service file is ready, action server 2 is ready, and then we call the action client to that. So first of all, I separate this service server in 3 parts.
Mm-hmm.
The first is the select the minimum laser of the lidar, and then rotate until the minimum laser is in front of the Turtlebot.
I see.
Then we move forward to make it close to the wall on 0.3 meters. Then we stop and turn to the left to put the robot parallel to the wall. So that's all I do the service server. After this, the service server send a message true.
Mm-hmm.
So then we wait 7 seconds. The remain.
That's where we saw it when it found the wall and it stopped a little bit, and then it started again. That's what you're talking about. Okay.
Yeah, that's what I'm talking about.
Cool.
We wait 7 seconds, and then we call the action client.
And why do you wait 7 seconds? Is there a particular reason, or you just want to separate the process more clearly?
I just want to separate the
That's
project.
good idea.
So I prefer to actually when the launch start, I wait in the main where is the action and service client 3 seconds to make in order to start the service server and action servers first.
Oh, okay. So you first do that. Yeah, because sometimes, oh, so it looks like it finished. Seems like. What are those numbers total? I'm assuming it's the distance, but it is, right?
Yeah, during the server action sends the feedback current distance total, and the program finish when I put the distance of 5.2.
I see. I see.
It's just in simulation, but I think in real robot must be 6 to make.
Well, I think that was pretty close. It started really close by, but yeah, I mean it's depending on the odometry, and obviously in the real world you'll have a little more error, so maybe that's the reason. But that was a perfect behavior. I really liked how smooth it was too. So can you just explain us, talk us through the code a little bit so we can understand each part?
First of all, have the find world servers. I make a good practice on C++. So
perfect. I like to see that. Yeah, header files.
Header files. I put all of them on classes. So I create a server class, a null handle, the ROS service and the subscribers for the find wall servers.
Yes.
That it's sub.
Oh, even
I
the
create a
notation you have right there with the
yeah.
sub underscore. I think that is there a reason why you did that, or
No, it's not a reason.
so it's a. I'm not sure if it's actually the underscore goes before or after. I can't remember, but there is a good practice standard, sort of like the way engineers should code ROS in C++. And for the subscriber and the publisher, they recommend putting an underscore like you did there. So that's why I was wondering. So nice.
Really? Oh, okay.
Yeah, yeah. I'm sorry for interrupting you.
No, no, no worries. After I create a vector float or laser range publisher and the minimum lasers. Uh, Velocity and laser scan. Okay, I want to explain the sensor callback. Has two parts. First of all, when I call the sensor callback, make the vector that I initiate here, vector floats, and I put all the information of the message range of the laser callback in this variable.
Yes.
After
Okay.
this, I create another function to make transform the data that I want. First
What
of
do
all,
you mean? Okay.
I select a group of lasers
Uh-huh.
for right, front, and left. So to make more precisely on the laser scan. So first of all,
Right.
I create a front laser. It's a vector. I just copy of the laser range, but I have the information of laser scan range, the position through 3050 and 3071.
Right. So
And in,
you're grabbing those values with this So you're grabbing from 350 to 371. So
yeah,
that's the front. And what is
and I
that
copy.
begin function? What does that do?
What
So
is that?
it says
The copy function?
laser range dot begin. What is that begin method?
Begin.
Yes.
It's the begin of the laser range.
Right. Okay. Got it.
Yeah, that's why I put this and this to make the range that I want to.
Okay.
Sorry, select. And I insert all of this on the front laser.
Mm.
Uh,
And you do
since
the same
I
for the right and the left, I'm assuming. Yes.
yeah,
I see.
I have the all information for laser. I call the variable min from laser,
Uh-huh.
and I put use the function min element of the front laser through begin to the end. So I have just one number of float
Great.
from this variable. So I use these variables. And it's the same process to the right and left lasers.
Good.
Then we have the service callback. First of all, I stop the robot just in case there's an error or something.
Mm.
Initialize the flags front, close, and parallel, and make a little stop. We start with the first while, that is the front.
Mm.
So we make just once again. This mirror laser, it's more than mean left laser. Mean left laser, we go through the left. If another mean left laser is more than mean right laser, go to the right to select to which side turn. After this, we can move this part of the code and select if the mean right laser it's more than the front right laser and the mean left laser is more than the front laser. in order to make in front of the wall.
Mm.
And another important, I call the transfer data function to actualize these variables. And another important part is the spin once. Spin once uh, make actualize the data from the laser scan for the variables that I use. So the spin once makes that all the callbacks in queue has been called. So we make I put this code to actualize the laser scan, and we
Keep it spinning.
and keep it spinning. Yep, that's what. Then I stop robot and go to the closed file. And once again, we transform the data. Like it's just close to the wall. It's time to move in front until the midfront laser should be less of 0.3, and I put backward and publish. True. We break the loop, and again the spin wants to actualize the laser scan. So to stop to finally we get into the while with parallel. We turn the robot to left until the mean front laser is more than the mean right laser plus 0.4, and the mean left laser is more than 0.3. With this condition, we know that the robot is on parallel of the wall, and stop and center. And that's all the service callback.
Cool. Cool. Very clear.
Yep. Then we have the service action. The construction action, making execute. We create a publish star, so the goal success and false, and we call the odom subscriber, because in this part of the code, I need to use the odometry of the robot to. Then let's variables to move. No, the odom callback. Thanks to TF modernization, we can obtain the yaw movement,
Right.
to make the position of orientation and zeta. So we get the matrix, it's a bar on roll, pitch, and yaw, and after we just use the yaw. So
We just need
that's
that.
why I use it.
Right.
Yep.
If it was a drone, we would need the other ones or something
Yep.
like that.
Yeah, if you're a drone, we need the pitch and roll to make the establish. I mean, then when the action client starts, the robot making stop, send the success equal to false, initialize the feedback, its current total equal to 0, and okay, we send the info that the action class execute is called, and then meanwhile success is equal to false. We have to put all the information of the odometry and make it Euclidean distance, and we save that on the feedback current total.
Right.
And we publish in a certain time, and we stop when the feedback current total is more than 6 or very soon simulation. Sends true, and the callback ends and send the odometry of the circuit and see it as success. Finally, we have the main of the program. First of all, like I said, we wait 3 seconds for the
Oh yes, I
action
remember.
action service server. We call the server, create a service client, and the variable of the find wall service, and uh, wait for the response is true or false. We see that, and if the server response well found is true, we make all the action client. Else, we send an error well found is false. And here in the action client, actually, we need to move the robot in order to follow the wall.
Uh-huh.
Meanwhile, the odometry is actualized. So I call this, while the state result is simple active or pending, we keep on the while with actualize the data from the spoonware. I call my node to transform the data of the laser and put the velocity linear set on 0.05 meters and make it all the logic from the robot follow the wall.
All right.
And this fragment of the code done when the state result changes to success or warn or error.
Cool.
And that's it.
Do you have a main function in this file?
Yeah.
I mean, in the main CPP, main.cpp.
No.
So you just, all right, I see what you're, can you go up a little bit more? All right. So you don't have like a main function, you know, like in Python, for example, where you at the bottom you have the main, where you initialize the node and then spin the node.
Yeah.
All right. The reason why I'm saying that, I'm not saying, by the way, great presentation, very clear, very smooth movement, everything that we were expecting here. So congratulations, Ruben. Now let me do some comments. So first of all, I really liked how it seems like you have a little bit of experience already with C++. Is that correct?
Yeah.
Yeah. Okay. Yeah. Because what I see is that you already, for example, you already saw you had the function for the minimum and things like that, which is like the analogous would be like using NumPy in Python, which is a little more known because more people use Python. But for example, when I started with C++, I didn't know these things existed, so it just complicated my life a little bit more. I would have to do for loops inside of for loop to look for a value in an array. I see that you've already taken care of that, just using some functions that you use, which is great. So that's awesome.
Yeah.
Another thing, the reason why I talked about having a main function in your files is because I see that you do the spin ones. There's a lot of places where you do the spin ones, and I realize is to keep the laser data updated so you get new values. I understand that. But for moving forward, I'm not saying this is the wrong way to do it, but maybe this other way you'll find a little easier to, especially to not have to keep track of how many ROS spin onces you have. You can do a main function at the bottom where you call your class or whatever, and then you spin. There's another method called spin instead of spin once, that it just continues to do it. So maybe it would be a good idea to see how you can restructure. I'm not saying do it because this is perfect too. How can you restructure that so you can just see another structure of how it works, and with having the main function, which you know, it's also a good practice. But other than that, I don't really see anything, like any other suggestions that I might give you, because like I said, you look like you have a good background in C++ because this is really nice, clean code. And I love how you do the header files. This is always, well, at least for me, we always keep it in the back of our heads. Oh, yeah. When I need to do it, I'll do it. But I like to see that you've done it, especially because as your programs get more complicated, you will appreciate that a lot. And let me see if I have another question. I don't think so. Oh, yes. Just a suggestion. I mean, it's not a like something you did wrong, but it might lead to debugging pains, let's say. I see that you have a publisher for CommandVal in your action server file. And I assume it's because you wanted to stop once the action server is completed. You have a stop function.
Here. Uh,
Yes,
Actually,
yes.
I don't use it.
Oh, you don't use it. That's what I was
No.
gonna say. You don't need to do that. Obviously, this
Yeah.
might have been because you're testing things and
Yeah.
you want to put a publisher, because it's always a good idea to just put a publisher in case you need it. But yes, that's what I was gonna say, because you don't have to. So you can kind of separate your servers, your action or service servers, from your main behavior. And for example, you said you don't use it, but yeah, that was just my other thing that I noticed. But yeah, I mean, other than that, everything looks great. Do you mind stopping sharing your screen here so we can see our
Okay.
faces and wrap it up? Great. Okay, let me just fix it. Ruben, congratulations. I really like this. It was really good project, and I was really impressed because C++ is a lot harder than Python, and I see that you did a good job. Is there any comments you want to make about the difference between one or two? Anything that came up while you were doing this project?
Yeah, I think that the most difficult part was to uh, update the laser scan. So the way that I found was the spin once,
Mm.
because after this, I can, or actually I use the async spinner, and I
I see. I
complete
see.
by this way. But when I go to the real robot project, I always had a lot of errors. But there's no errors that I could see.
Right.
So I don't know
Where it comes
what
from.
I'm gonna do with this. Like, exactly. So okay,
Yeah,
I
you
tried
definitely
another
have
way.
more of those issues once you do C++. Like with callback functions get blocked, and you don't really know why. So,
Yeah,
yeah, that's interesting, and
yeah.
I'm glad you saw that spin once and that it worked for you. But again, take a look at that other one, the spin, just not once, and then how you can implement it in your nodes, because it's also another way you can do it.
Hmm.
All right. Well, awesome. Great job, Ruben. So, for everyone else that's watching, you can do what Ruben here did and take your ROS Basic courses so you can get started with robotics practice and becoming a robotics developer. Also, make sure you take a look at our other courses. We have over 50 courses, and we have things coming up like we have workshops. We have many different things. So I recommend you guys check it out in our site and yeah, do what Ruben did here. But Ruben, again, thank you very much, and I'm very impressed with your project. So congratulations.
Thanks.
All right, guys. So that's it for us. We'll see you guys in our next presentation. Well, actually, it's in a couple of minutes. So we'll see you there. And Ruben, hopefully we see you around for other things.
Of course.
All right, guys. Bye-bye from us. We'll see you next time. Perfecto.